All right, so trigonometry. So for trigonometry, we're going right back over to triangles. Okay, so triangles. And in particular, we are going to be dealing with right triangles. Okay, and almost any object can actually be taken back to the triangles. So that's one of the things that we're going to kind of work with on that. Still doing this. Move. Okay. It's not wanting. It's not like, I don't understand what it's doing and why it's being this way. And then that screen is still doing its own thing. Well, all right. We're going to just roll with it. We'll make it work. All right, so trigonometry. We're going to also, just for a note on a few things that kind of, to clarify, we use a Greek symbol. This is a Greek symbol. It's actually a Greek alphabet. It's theta. All right, so if you're familiar with any fraternities, sororities, doctor organizations, they always have Greek names. There you go. So what we use this symbol for is just like pi is also a symbol out of the Greek alphabet. We use this to identify an angle. Angle measures. Okay. So instead of like trying to call out the angle ABC or whatever, you might actually see theta in the figure. Okay. So the trigonomic ratios, and these are ratios that we're going to be dealing with. And if you can think about a ratio, what is a ratio? Just think about it. Part to part. Precisely, that's one way. How about my car gets 33 miles to the gallon? What did I just do? Yeah. Fractions are ratios, believe it or not. Fractions are also just division. Okay, so a ratio is a comparison of two quantities. So therefore, if I'm like comparing my miles to my gallons of gas, well, if I get 33 miles, that means I can drive 33 miles on 1 gallon of gas, right? Everybody agree? Okay. So if I went and said, well, I get paid $8.50 per hour, and I work 4 hours, what do we do to solve it? Well, in that case, we'd be multiplying, right? Because again, I worked 4 hours, so how much am I going to get paid for 4 hours? If I get paid $8.50 for 1 hour, then how many for 4? Okay, so when we have ratios, we can take that ratio and carry it out, just like we were doing with the 30, 60, 90s and the 45, 45. Okay, we can take those ratio values and carry it forward. So trigonometry is a set of the 3 primary ratios. And these ratios are what you've probably seen them before. And for starters, I will correct you. It's not sin. It's sine. Okay. And you've seen these on your calculators. Okay. There is also cosine, not cos. Okay, we're not cussing, we're not sinning in church or biblically. Okay, so it's sine and cosine, and we're not going to the beach to get a tan. We're going to have a tangent. All right, so those are our 3 ratios that we primarily work with. And again, there's 3 sides to a triangle, so there's 3 primary ratios that we're dealing with. Now, there are also inverses and things like that. That's something that you will get into when you get into pre-calc. All right, so there are more listings because you can do some inverse operations, but we're not going to go that far. So when we are also trying to identify these, we do refer to them as like the sine of theta, the cosine of theta, tangent of theta. In other words, my ratio is going to also include my angle measurement. Everything is going to be in a ratio based on my measurement. Now, I keep referring to it as a ratio, and this is why. All right, so if you go and Google trig table, now this is what I had to use when I was in school, okay? Because we didn't have a calculator that had memory chips. Silicon Valley hadn't been developed yet. All right, so after that fact, and they came up with memory chips, you know, those little things that y'all like to put in your phones. Okay, be grateful that somebody in my generation, a little bit older than me, actually developed those. So, you know, when we talk about the boomer generation, they're the ones that developed that. Okay, they're the ones that wrote the programs. They're the ones that sat down and said, you know what, I'm tired of carrying around this book full of these ratios. I'm going to program it into a calculator. So that's what they did. All right, so now when you go and you type on those buttons on this calculator, and I can pull the calculator up here. Now, there is one thing that you need to make sure. These calculators get reset. A lot of times y'all will actually go and turn them off or reset them before you like leave. If you do that, they're going to default to what is called a radian mode. All right, so again, let me get back over here and write that down. You will get the wrong answer if you're not in degree mode. A lot of calculators, including ones on the computer and out there in the world, will default to a radian mode. All right, so you do need to make sure that you are always in degree mode, at least for geometry. All right, I promise you. I will have people that will fail a test and come back and tell me that they did all the math correctly. Look, see, here, I did the math correctly. And the whole time, they were in radian mode. And so it comes out wrong. It's not that it's wrong, it's just not in the format we need it to be in, okay? So you need to go to the mode in your calculator. And as you can see, mine is defaulted to radian. And you need to change that to degree. You do need to double check, even on your online computers or calculators, whatever you're using, make sure it's in degree mode, okay? Because it will sometimes, it just depends. I think Desmos will stay defaulted to degree, but I can't promise that, okay? So let's go ahead and I'll show you again the trig table. And I guess my people online, you can kind of see why I was trying to share my entire screen instead of, but Melissa's watching a show, so she can't keep me up to date on what's going on. See, she can't even, y'all know how bad it is, Melissa? Yes, I was talking about you. You usually tell me what's going on, but you're watching your show, so you're not seeing. All right, so if I want to find the ratio value of, say, the sine of 25 degrees. And so I'm looking here, here's my degree, 25, and I want to find out the sine value. So I go over here to my calculator, I type in sine 25, close the angle. So it's always going to be the trig function and the angle measure, unless we're solving for the angle, and we'll do that on Monday. And when I hit enter, I get 0.4222618, and you can see it carries on and on and on and on. And what do we have here on my trig table? The same thing, okay? So again, all that this has done is that they put it on a memory chip inside the calculator, so you don't have to carry this around and try to remember how to type them in. because all I had was a little 4-function calculator that did nothing but add, subtract, multiply, and divide. And when I was having to solve, I'd have to go over here, find my function, get that decimal value, plug it into my little 4-function calculator, and get my answer. Okay, so that's just how technology has been friendly to us. They now have it programmed. Okay, so, but if you can understand that these are ratio values, that every single trig function, whether it's a sine or cosine or tangent, or even when we get into cotangents, cosecants, and all that in pre-cal, that is a value. It's a numerical number value. It does not change. Okay? So now, kind of jumping over here, let me actually go back to pulling my screen up where I have my peoples online so I can see what y'all got going on. All right, so now, when we're dealing with these ratios, we are dealing with right triangles. So for instance, if I have a triangle, and I'm just going to use a default triangle here, all right? And because I know it off the top of my head, I'm using the Pythagorean triple of 6, 8, 10. I'm going to label this as my angle theta, all right? The set ratios for these, the sine is going to be the opposite side over my hypotenuse. Okay, so that's the ratio that is being checked. All right, so if we wanted to, in this situation here, the opposite side of theta is 6, right? And my hypotenuse is 10. So we could actually, let's look at that, 6 divided by 10. If I wanted to find this angle measure, so it's 0.60, I could actually go back over to my trig table and find, I did the sine, right? And go find 0.60. It's about 37 degrees. Okay, so all I did was I went and found my sine, 0.60, and he's about 37. Okay, so you can kind of see how we can switch back and forth on our trig. All right, so what we're going to be doing mostly today is just identifying and playing around with these ratios. Okay, so we'll get to more solving and using them tomorrow and Monday. All right, so cosine is the ratio of the adjacent side and the hypotenuse. And the tangent is the ratio of the opposite side to the adjacent side. Okay. And again, that's where we're getting our little set of values. Okay. So if we wanted to go ahead and look using our triangle here. Go away. There we go. Let me slide it over. And I actually want to, it's probably not going to do it. Nope. I wanted to move this guy over. Oh well, we'll just rewrite it. I'm not going to try it. It's already being so fussy. I don't know if I could actually make it do what I want it to do right now. All right, so if we want to find the sine of theta, just like I said, it's going to be the opposite over the hypotenuse, and that's going to reduce because we can reduce both of those by 2, right? 2 goes into 6 3 times, 2 goes into 10 5 times. So the ratio of my two sides there, my sine, is 3/5. Cosine of theta, adjacent over hypotenuse, And so we have to recognize that this is my adjacent side, the one closest to it, okay? So adjacent side is going to be 8 over the hypotenuse, which is 10. And again, we can reduce it. So 4/5, right? And then our tangent is going to be the opposite over adjacent. And again, it can be reduced to 3/4. Okay? And again, just remember, these are numbers. So we got to treat them as such. All right? So each one of these represents a value. All right? Now, there are a couple of things, some ways that are taught to, I think my headset's about to die. Hang on, let me get logged in over here because y'all can kind of hear me from there. And I charged it this morning. I guess I've used it too much. Okay. All right, guys. Sorry, we'll see how long my headset stays connected.
All right. I can hear myself. Hang on. Okay. Can y'all hear me okay? Oh, it's doing that again. Or was that you? That was you? Okay, not there. Okay. Yeah. It is. It's going through there. Okay, that's what I need to do. Hang on. Okay, now. Y'all can hear me okay? Or did it mute me totally? Okay, cool. No, y'all can hear me. All right. So I have to turn off the other speakers, or else we end up with the inevitable echo. So, all right. Okay. So now, there are a couple of things and a couple of ways that people try to remember. And there used to be a saying, which was Sakatoa, and there was like this whole Indian story about it. And then people got their feelings hurt because it was talking about Native Americans, and so people got all hurt about it, and it was inappropriate. So they don't use that story anymore. I was taught Oscar has a heap of apples. Basically, it was just another acronym. And for years and years and years, the only way that I could actually spell Sakatoa was to spell out Oscar has a heap of apples. Okay, but anyway, there are many acronyms out there to help you remember these trig ratios and the appropriate setup. And when we are actually solving problems, I will actually ask you, well, what do we have? What are we looking for? Well, which ratio is that going to be? So you're going to want to have a way, and I'm going to show you two. All right, so again, one was, they call it Sakatoa. So it's sine, opposite hypotenuse, cosine, adjacent hypotenuse, and then tangent, opposite adjacent. Okay, and that's where they get that Sakatoa kind of deal from. Also, ways that let's see, let me get this image here real quick. I always liked this one, and I was able to actually put it up on the board and keep it there for a while.
Let's see how quick it's going to actually throw it up there for y'all because it's been acting up today. Yay, it worked. Okay. So another one, again, it still goes back to SOHCAHTOA, but again, it uses these nice little triangles as another means of remembering. Again, our sine is sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And again, those are set ratios. All right, so y'all want to work, well, we've already worked one set of samples. Let's work another, just a random triangle, okay? Because you will get into some solving. Wait, did it go blank? Or what? Huh? Oh yeah, I'm gonna pull it back up. I'll give it back to you. And I'll probably end up drawing on the back and forth. Okay, so it'll show up again. All right, so let me just, and we'll say this is 27 degrees. And that side's 5. Okay. So now, and again, I'm just randomly grabbing a value. I'm just randomly grabbing some information. Like literally just randomly grabbed 2 numbers out of the sky. One was 27, one was 5. And voila, there you go. Okay. So what we want to do is we're going to solve for the other side and also for my hypotenuse. Okay, so we're going to solve for both sides. And again, we need to remember these are ratios, these are numbers. Okay, so first thing, this is my hypotenuse. I always identify my hypotenuse first. Have y'all noticed that? Even when I'm not being asked to do anything with my hypotenuse, it's the first thing I always identify in a right triangle. And that's because that immediately separates it from my legs. Okay, so I always immediately, the first thing I do is find that hypotenuse. From my angle measured here, we are given 2 other additional information or pieces of information. So from my angle 27, 5 is going to be opposite. And X is going to be adjacent. Okay. So again, opposite because it's on the other side, adjacent because it's part of it. But the hypotenuse is always going to stay special. The hypotenuse is never going to be anything but that. Okay, he is my special side all the time. So for this one, we're given the measurement of 5, right? And he's opposite. So if we think about our functions, okay, we had again, it's
it has software in it.
Technology.
It's on again.
Technology is like, more than likely our server's crashing or something like that. All right, so again, sine is opposite over hypotenuse. Cosine adjacent over hypotenuse. And tangent opposite over adjacent. All right, so those are our 3 functions, right? So far good? So thinking about our problem, we're given an angle measurement. So if I would go back to my trig tables, what was my angle measure again? 27. So we would go find 27, and you can see here, I'd be using
those numbers, okay, to solve for this. So again, these functions actually have that value. All right, but again, we're not going to give ourselves a headache. All right. If you're looking at the pear deck, Evelyn, no. The pear deck, apparently, that's why I don't really, there's some things about that I don't like about pear deck. I can see y'all's data, but I can't, it won't give you a grade or tell you right or wrong, which I will withhold my information until I talk to our district's specialists and tell them no pear deck, okay? Because it's just not, it's not providing the feedback that I'd like for it to provide. Where Nearpod gave y'all kind of immediate feedback pretty quick. So anyway, all right, so we have again opposite. So out of my three functions, which two would I want to consider using? So tangent would be one. The sine, yeah, sine, yeah, it's sine. No sin, it's sine. Yeah, but that is what we're gonna do. It's like when you look at what you've got, we have a 5 that's out there, it's opposite of my angle. So therefore, right there, that told me the two types of functions I was gonna need to use, the sine and the tangent. Okay, because again, they both contain the opposite in their ratio. Now, if I want to solve for y, which is my hypotenuse, I'm going to use the sine of my angle measure, which this time our angle measure is not theta, but instead is 27. It's going to equal the opposite over my hypotenuse, which is y. Okay, now just bear with me for a minute. Everybody can kind of see that? All right. Again, sine of 27 is a number. All right, so when we go through and solve this, we need to consider this is a value. That whole thing is a value. All right, and he is over 1. Because again, it's ratios. And when we have two ratios equal to each other, we have a proportion. So we're going to cross multiply and solve. Like literally. Cross multiply and solve. All right, so notice, again, I'm keeping my trig function all together. I'm going to divide it out. And I'm going to divide it on both sides. And again, it's a number over itself, so that cancels to 1. And I don't know. Where's my calculator? All right, so again, make sure we're in degree mode. We are. And then go to mode. And make sure, and then scroll down, I think it's 4 down on the top. And some of them may have already, because I had a full class this morning. So, but then some people reset the calculator as a default when they get done. All right, so when we put this in, we want to actually go 5 divided by, and I like to be safe and not sorry. So I'm actually going to put my parentheses, the sine, my angle measure, close out those parentheses. Hit enter. Here's your answer. Okay, so our value of y is 11.0. What is it? 13? 13.
Second question. If we would have
Yeah, just make sure it's a degree mark. That's why I was saying, like, even if you're using the mathematical calculator, anything like, make sure it's a degree mark. That's calculating with a degree mark. For testing. Yeah, for like STAR testing and SAT and stuff like that, our school just like right over that because they put them in test mode and programs are disabled and things like that. But no, for this, you're welcome to your own calculator. We're already using them. Yeah. So no, it's perfectly fine for me. I don't mind. I know that a lot of people are also using like Mathway online for a calculator or Desmos online for a calculator. The only thing about Mathway, I know that a lot of times it will actually work problems for you, but be careful because of the formatting. The formatting will sometimes be way off from anything we'll do because it can't totally fully, interpret what we're doing in class. It's helpful. It's a helpful tool, but it's not going to be accurate all the time. As far as that's how I discovered Mathway. Actually, y'all didn't know that. I was getting weird answers on a test, so I started Googling it and found it, and I was like, oh, okay. That was about 10, 15 years ago. All right, so now we have found our hypotenuse. We're going to go through the same process, but like we said a minute ago, we now need to find our adjacent sides, so we're going to use tangent. All right, so
Miss Clark.
we'll go purple. So now we're going to do the tangent of 27, and that's going to again equal opposite, which is 5, over our adjacent side, which is x. And since x is in the bottom, I can tell you we're going to end up dividing again. Okay, and that's just again, that's kind of how ugly things get when you actually make up a problem, which is what I did. I made up a problem, and so you get ugly values. All right, so it just never turned out pretty. All right, again, this is over 1, cross multiply, and we get x, tangent 27, equal to 5. And again, keep your trig function in parentheses unless you're real careful about where you're placing it. If you type it in the calculator with the x on the wrong side, guess what? It's going to calculate the whole wrong answer. So that's why I'm stressing the parentheses. All right, we're going to go ahead and divide out the tangent of 27. And there we go. So 5 divided by, this time tangent, there it goes, 27. It's not typing. There it goes. Why does technology have to be that way? 9.81. All right,